Okay, so here's problem 25. This is a pretty well-known class of problem, or at least MathCounts likes to use it a fair bit. So Avi and Hari agreed to meet at their favorite restaurant between 5 o'clock p.m. and 6 o'clock p.m. They have agreed that the person who arrives first will wait for the other only 15 minutes before leaving. What is the probability that the two of them will actually meet at the restaurant, assuming that the arrival times are random within the hour? Express your answer as a common fraction. So we set up a little table. So here is when Avi arrives, and here's when Hari arrives. And this is 5 p.m., 6 p.m. And so what this amounts to of so this part over here about arrival times are random within the hour, what that really means is that we're choosing like a random point on this 1 hour by 1 hour grid, which will represent the time that Hari arrives and the time that Avi arrives. And so we now have to figure out the probability that they actually end up meeting. And they have agreed that the person who arrives first will wait for the other only 15 minutes before leaving. So that means we'll just consider for each one of Avi's times. So let's say Avi gets there at 5 o'clock p.m. He'll wait until 5:15, at which point if Hari arrives, so that means that Hari has to arrive between 5 and 5:15 if they want to meet. Similarly, in general, as Ari goes on, so this line represents Hari arriving before, this represents Hari arriving before Avi leaves, this line that I've just drawn. Because if we think of it in like the coordinate plane, this line is like y equals x equals y plus 15. So the time that Hari arrives is the time that Ari arrives plus 15 minutes. And we have to be on this side, because if Hari arrives after Avi has already left, it obviously won't work. And on the other side, the same thing is true. Because it's not just, because what if Hari arrives first and then Avi never arrives? For example, if Hari arrives at 5 p.m., then Avi has to arrive by 5:15. And in general, Avi has to arrive within 15 minutes of Hari arriving. Not very to scale. Oh, it's just, so yeah, now this is a little thing called the geometric probability, and it's where we use geometry to represent probabilities. It's quite a powerful technique. And so we'll just label this with probabilities instead of like minutes. It's just scaling down. So these guys will only meet if their times end up in this middle corridor, if they arrive pretty near each other. And the area of this little part is just 1. It's 1. It's 1 minus the area of these two things. And those two things together form a square with side length 3/4. So it's 1 minus 3/4 squared, which equals 1 minus 9/16, which equals 7/16. And that's the probability that they end up meeting.